Hello, everybody, and welcome to today's Open Device Management Interface call. Thanks for joining. As usual, the call is public and recorded and will be shared on YouTube, so please be mindful of the comments you make and the information you share with the group. First up, I wanted to get the status on a few things before we proceed further. One announcement on my side that we have released the 2.8 version of we have released 0.12.0 version of the interface that went along with the Volta 2.7 release. So that's good news. Even though they're not tightly coupled, we did that, and it will be in the blog post. So that's good information. But on the next steps, Amit, had you given some thought to the timing clock API?
So maybe Andrea, you need to help me remind on this. I'm not sure on this thing, the API thing, but we did work on the bits. We had to introduce a new protocol for one of the enum values on the protocol for the port. So that part is done, the bits part of it, but I'm not sure on this timing clock API thing.
Okay, I think that's good enough for now.
Okay.
To introduce the endpoint for the protocol. If anything more arises while implementation or implementations are getting done, I would say let's take it from there and reassess whenever we get more information.
Sure.
I think this is sufficient, and this is all I was asking for, just to get this bits protocol. Thanks, Amit.
Okay. We talked about the BBC implementation last time. That is done, which is good. So on my side, there's still some things that need to be clarified before I can proceed on the DMI testing on the Adtran OLT I have in Berlin. I don't have any news on that front, so unless Holger, you have any, I would postpone discussing this topic.
Yeah, I don't have anything.
Okay, good. Then we can wait on that.
Yeah.
So before we move to the progress that Radisys is making, which I know is going to take a long time because it's a lot of great progress. Anybody has any interface related topic that they want to bring up, or something that they found that they want to share with the team? No? Okay. Then maybe Sean, you can introduce new members of the team and share a little bit on your progress, Sean or Chanda, Babu, whoever prefers.
Yeah, I think Chandra has the presentation. Do you want to go ahead, Chandra?
Sure, Sean. So this meeting we have Shivana Gowda, who is a lead engineer and who will be contributing to the OpenDM agent development and the integrations. And we also have Prince Pereira, who is the lead from Radisys working on the Open Device Manager, and he will be contributing to the community on the device management stream. And we have Uday, who is an architect from Radisys, and he will be contributing to the Open Device Management development and integration. And Babu is the program manager. I think Babu attended last time. Yeah, that's all, Andrea. We have people now joining in this meeting. Thanks a lot for the.
That's great. Nice, everybody. Nice to meet you. Thanks for joining. Your contribution are very welcome. So, Chandra, maybe you want to give us some thoughts around the progress you have made on the implementation that you're working on.
Sure, Andrea. So we are, maybe I would like to share my screen.
Sure, go ahead. Let me stop my sharing.
Please let me know if you're able to see the screen.
Yes, we can.
Okay. On the progress, we are getting started. Basically, we are working on the OpenDM agent component that runs on the device. And the OpenDM agent will implement all the hardware, software, events, and metrics RPCs as defined by the DMI. And the OpenDM agent will implement the device context management, the UUID, inventory, and states, and the basic FSM required for software upgrades. And DM agent shall consume the threshold configuration and generate the TCA, threshold cross alerts. And if message bus endpoint is configured, it will publish the events and metrics on the Kafka. And if gRPC streams is configured, it will publish on the gRPC streams. And as discussed in the last meetings, we are proceeding with the persistency of northbound configuration on the device itself. And it is the device responsibility to restore the configuration after the device reboot. Reason being, there is a deployment architecture wherein NEMs can directly control the device and manage the internal states directly. So to adhere to this, we are going to implement the persistency on the device directly. And we would like to also work on a second deployment alternative wherein there can be a device manager which exposes a single endpoint for the NEM components to manage all the devices. And the devices might have just gRPC for northbound connectivity for both procedure execution as well as asynchronous messaging of events and metrics. So we are considering the gRPC streams as a option to publish the events and metrics from the OpenDM agent to the device manager. So from Radisys, we would like to upstream both OpenDM agent implementing the community-defined DMI interface, as well as the Open Device Manager, which is a thin layer which terminates the gRPC on the northbound towards NEM and communicates on the device interface, again, which is DMI, and adapts the Kafka, basically the events and metrics coming on gRPC streams to Kafka. So that we have captured it here down, that it performs the adaptation of events and metrics from streams to Kafka. Apart from that, as it is an aggregator of all the devices, for each device, it will store some basic information about the configurations and the current device status. And implementing the server on the northbound and client on the southbound. And this Open Device Manager architecture is generic enough so that we can plug in any other custom adapters. So it is very, very similar to the Volta architecture, wherein on the northbound, it talks to the NEM on the gRPC, and for events and metrics publishes on Kafka. And on the core, it will have the context management and the persistent KV store and events and metrics related info. On the southbound, it can work with the different adapters. One of the adapter can be the gRPC based adapter implementing DMI, and we can have any other proprietary adapters that the vendors who already have a solution can plug in to this solution. So this is overall on the two streams we would like to contribute. Any questions or inputs on this? So we will be considering both options. That device also should be individually able to cater to all the DMI requirements. And this Open Device Manager is an additional feature. Okay.
I think this is great, as we discussed. That's my thinking. Anybody has any thoughts on what the proposal from the Radisys team is? No? Then I think you can proceed.
Thanks, Andrea. So as we are considering gRPC streams for events and metrics, so we need to have a streaming RPC established from the client towards the server. So we have two options in front of us. One is having a stream for events and a separate stream for metrics, so that whenever a device is asked to be managed, this RPC shall be executed, so that there is always a streaming session that is available for the device to push the events and metrics asynchronously on the streams. So this is a separate RPC for each metrics and events. There is a second option wherein in the hardware management service itself, we have the indication message defined, which is one of event or metric, and enable indication wherein device can send both events as well as metrics on the same streaming channel. And the factors to be considered are whenever basically it's a challenge with gRPC stream. Whenever there is a client which restarts, or maybe server, that is device restarts, so we need to establish the streaming connection again and see that all the messages are again reaching the client as expected. So in case of connectivity breaks, there can be a couple of messages getting lost which are in transit. So that is one thing we have to address. Maybe persisting the messages on the server until it is consumed at the client is one option we can consider. This is one thing. And second thing is mainly if we want to prioritize the events over metrics. Let's say events, I call it as alarms for, let's say, SFP pulled out or SFP plugged back. So events should be produced or consumed at a higher severity or a higher priority than the metrics. So metrics can be given a best effort consumption, and events we may want to consume it on priority. That's one more aspect we wanted.
Chandra, we lost you for a minute.
Is it audible now?
Yeah, now you are audible, but you were lost for a minute.
Okay.
Maybe you can repeat.
Okay, sure. Thanks, Babu. So two things. One is whenever a device is not reachable for some time, we need to break the previous context, clean it up, and re-establish. That's a challenge with gRPC streams that we have to address. Second point is if you want to prioritize the events over metrics, so that the alarms are processed at almost immediately, and metrics / KPIs can be processed at best effort. That's one aspect we can consider between choosing these options. Would like to hear from the community any thoughts or preferences among these options, or any other option that can be feasible.
I do have one comment on the indications. Have you thought maybe of breaking the event and metric indications into separate RPC streams so that they can evolve separately?
Okay, so two different streams is what, can I take it that way? So that they can,
I mean, for on your management service side, having the server having two different endpoints to one generating an RPC stream of just events and the other one of just metrics, and that would allow you to keep it more specific to the service that you're broadcasting for.
That was option one. There's two options here.
Oh, okay.
One is the events and metrics
Oh,
are
okay.
separate,
Oh,
and the other one
sorry.
is combining together. So I guess
Okay.
the question is, is there any strong sentiment about going one way or the other? I think
Okay.
we kind of like the option one model, but we're presenting both models here to see if there's any strong feelings one way or the other.
Okay. Thank you. So I vote for number one if you need another. It just seems more easy to manage or manage the code.
Yeah, so in option one, what I say is that we have two separate services. Maybe we can have one service itself, right? With two, the service could be the same, the gRPC service, but you have two separate RPCs within that service.
Yes,
I mean,
Yeah, I like the option of having one gRPC service for the streams, but two RPC methods. Yeah, that simplifies it on one end, but keeps the flexibility on the other.
Yeah, currently we are thinking to add this RPC into existing service, Amit. So already in the hardware events management service, we have the native events service. In that, we are adding a new RPC. Only RPC we are adding here.
Okay. So you're not planning to introduce a new service altogether. Okay.
Yes. Only RPCs we are proposing.
Okay. Yeah, I think that's fine. Yeah.
So one thing is, Olga mentioned that easy to manage or suppression of concerns. And second is, if required, we can prioritize the events over metrics. Any other input? We can move to the next point.
So regarding this prioritization concept, maybe I'm not completely convinced about this, because we can do it only at the application code, right?
Yeah, it is. Yeah, interface should not be really. Yeah, it is just a application thing, Amit. Yeah, interface should be agnostic. Yeah, if required.
Because say the TCP connection, right? Ultimately, at the transport, what I'm saying is at the transport level, we can't do anything about it, right?
Yes, Amit. Yes, on the transport we cannot really prioritize. Only how you consume. Maybe if there are
the application code. Okay.
Yeah, messages lined up, you can prioritize. Yeah.
Yeah, it's an implementation detail, but keeping them separate allows for it.
Okay. Yeah, sure, agreed. It's an implementation detail. And next point we wanted to discuss is, because we have a gRPC streams between the device and the device manager, so we see there is a need for heartbeat check to check on the device connectivity status and to re-establish the gRPC streams. So for this, we are going to just propose that the mechanism we already have on the OpenVolt interface between Volta and the device, the heartbeat check RPC, same we would like to leverage here as well, so that if the connectivity is broken towards the device due to network issues or server down, there should be a mechanism to re-establish through a heartbeat mechanism. So initially the heartbeat RPCs can be with a fixed interval, let's say 5 seconds or so. And whenever the gRPC times out consecutively, then you mark the device as unreachable, and client can clean up the streams context and related data. And once the device is marked as unreachable, then we can do the heartbeat gRPC with the exponential backoff algorithm, again setting with a maximum limit, so that you keep increasing the limit as you back off exponentially. And in the further retries, if the connection is successful, then the device is marked reachable again and the streams connection is established for events and metrics. Any inputs on this heartbeat? Because this seems to be mandatory for us to go with the gRPC streams.
So Yeah, so just for my understanding, so my understanding was that the heartbeat is really to check for the readiness, right? And not really the, because if the connection goes down without the heartbeat also, you would not be notified of that, right? When you are waiting on the stream, you would get an error there. So just to find whether the connection is broken or not, you don't need the heartbeat check. Isn't that the case? But to find out if the other party is ready or not, then we need an explicit application level messaging saying that, yes, I'm ready or not.
Agree, Amit. Basically, what you're saying on the streams itself, when the connectivity is broken, you will get a notification that the peer is closed the connection, or basically down, and more about health check.
Yeah, that itself could be the trigger for you to reestablish the session of the stream.
Amit, just to add over here, it is a unidirectional streaming RPC. So if it was a bidirectional, then we would have agreed it. But since it's a unidirectional, there is no way to detect it. Since the streaming happens from the server side towards the client would be the device manager or anyone who is it. So there is no way to detect it.
So if the connection breaks, won't we get a error on the server side where, on the client side where we are waiting on the stream?
No, a client side would not get, it will be waiting on that this one on.
Receive. On
sometimes it does not report. Yes, it will not report also. Sometimes.
Okay. Okay.
So maybe we can again do some sort of POC and cross check, but this is what was our observations earlier.
Okay, because I was under the assumption that we should be able to figure out from that. But in any case, having a heartbeat is good to have the readiness kind of on of a logic, right? Or to check for the readiness of the server.
Yes,
Yeah.
yes, agreed.
Yeah, do you know that there's actually a gRPC health checking protocol already defined by gRPC that provides much of this capability. So you might want to look at that.
So as we have explored, gRPC provides an inbuilt retry mechanism, but when you are executing an RPC, sure, we'll just check whether this inbuilt gRPC mechanism can be leveraged. And it has, yeah.
Yeah, I mean, besides just actually on the gRPC call itself, there's actually a gRPC service for a health checking protocol that a server could implement. And it provides a capability to check either the health or to do a watch point. So if you just Google gRPC health checking, that might provide some information.
Yeah, sure. We'll have a look at it, and yeah, thanks for the input. Maybe
Okay.
we'll consider that if it can serve our purpose. Thank you. And next couple of points we wanted to run through were the gRPC port number for the OpenDM agent. We see that 9191 is being used for the Open OLT agent. Can we consider using 9090 as the default gRPC port number?
That works for me. 9292 as well.
Okay.
But in any case, it should be configurable to be changed at system bring up time.
Yes, Amit. Basically, we would like to have the configurability but have a default port if not configured.
Yeah, that's fine. Yeah.
Sure. And next point we wanted to bring up was on the admin state on the hardware components. Basically, we see that with respect to PON port, already it is being managed by the OpenOLT interface. And also here also we have the set hardware component info, basically, which sets the admin state. So what should be our implementation? Like currently in our solution, we have the BAL for managing the PON port administration. So what is implemented in the OpenOLT, we will go with that for the integrations. And here we may not really set the admin state on the port. Is that fine? If there is an API call made to set the admin state, we'll not really go and reflect it on the hardware PON port.
So if I understand your question correctly, Chandra, what you're saying is that change of admin state for the ports is not something that we're planning to implement on the device manager, right? Or the device agent. Because
yes,
it is currently being done by Volta.
yes, sir.
I would agree.
Yeah, I think that's how we could keep it for now, unless we come up with reasons to rethink on that.
Sure.
Yeah.
And next thing is we try to update the community repo with the CPP related make file plus the building.md, basically setting up the required dependencies for the gRPC CPP plugin and checking in the auto-generated file. So there are a couple of Jenkins failure issues. We have requested Andrea if we can help to overcome the same.
Yeah, as I said, I'll take those on. It's just I haven't had the time between yesterday and today to deal with those. It might take a little bit. I'll get something done as soon as possible.
Thanks, Andrea. And we are considering to use the ONLP for the SFP, fan, and thermal sensors, and also the PSUs on the OpenDM agent implementation. This is just information. If you have any other alternatives, would like to hear.
I don't have any, and I don't know of any that exist that are open source and that we could leverage. Holger, do you have a proprietary implementation, or is it something that is it open? Maybe it's not open in the sense that we can see it, but maybe it's open in the sense that we can get it from somewhere.
Actually, I don't know. We're not using ONL, and it might be our own implementation.
Okay, I see.
I guess it's our own implementation, but I'm not really sure about this. Sorry.
Okay, no, it's fine. No problem.
Okay, thank you. And on the persistency of the configuration on the device, we just evaluated option, and we see that we are going to use a flat file, and we would like to use the JSON as the format to store and retrieve the configuration. This is just implementation detail. We just updated. Yeah. Any inputs on that here? It's implementation, I agree, but yeah, JSON is what we prefer to use as a format to store and retrieve.
JSON is fine by me.
Yep.
And the next point we would like to bring it up is the alarms persistency on the device. So we categorize the alarms into two, basically the hardware alarms and the TCA alarms. when I say hardware alarms, these are more about, let's say, the SFP pulled out or inserted. So that's a hardware event, and the TCA are primarily based on the threshold configuration, we rise and clear. So is there any thought here, basically what should device persist across the reboot? Every time for the hardware event, at least it can scan through all the ports and identify if there is SFP there or missing, and it can report it. For whichever ports that are enabled, maybe we can start reporting the events. So we would like to build it fresh on every time device can scan through the ports after it reboots and report the status. That is one option. Or it has to persist whatever alarm it raised towards the northbound and check that information before re-raising again. Or if condition is cleared, and it can just clear that alarm. Yeah, would like to hear how exactly you see overall. Again, it's something that interface should not bother. It is about device and the NEM or the northbound system to take care. Let's say already there is an event generated. If device raises the same event again, maybe the northbound system can ignore that, or maybe consider this as the latest and delete the previous one. For the threshold cross alerts, once the alarm is raised, if the device is rebooted, if let's say the temperature going up, again it sees that the temperature is beyond what was threshold configured, it can detect the condition again and again re-raise up to the northbound system to keep which alarm. Any guidance here would help.
So we are using persistency not on the device, but on in our device manager, which runs off the device. And this one is taking care that events which are sent to a northbound system of a device manager are really only, you should only see one alarm and then the clear alarm, but not, I don't know, 15 alarms in case the device reboots 15 times. And in principle, you could do the same, because you showed us that there will be an agent in between. Sorry, I forgot the name about this, which is also running off the device. So it doesn't have to be the device which has a logic to make sure that alarms are only sent once.
Thanks, Holger, for the input, but we would like to have both implementations. Mainly, the device alone should be able to manage with the NEM directly. And we take your input that device manager can maybe report only one alarm. If it is already raised, maybe it can just ignore it. But in this case, if a device has to talk directly to NEM, how do we manage the hardware and TCA alarms? Should we expect NEM to take care?
So my, I think as we discussed, my take is that both options have pros and cons. Sending the alarm and then the cleared would have the NEM to keep track of what's immediately cleared after getting sent, and that has a flood risk, as we discussed. Not sending that alarm might yield issues in terms of not having that history in NEM. I was thinking about this a little bit even today, and I think that given that we have the API to retrieve alarms that have been that have been on the device, we might not want to send the raised and cleared ones, and just if NEM cares about history, it should get them from the list alarms API. But that's maybe just my thought. Anybody else?
So, Andrea, one correction, I don't think there's an API to get the events that are there on the device. It's just, I think, we can get the events that are supported by the device, that the device can emit, but not the events that have occurred.
So we don't have a history there. Okay.
No.
Okay. Then my comment is not valid anymore. Then I think we should send all of them and let them take care of it. But that's maybe my thinking.
So I think it's difficult to come to a conclusion right away, because if we send all of them, right, now it depends on at what frequency is this event getting generated. It could be, I don't know, right? It depends on the frequency. And as you said, it might create a lot of noise, because it really does not add any value, right? If the temperature is above the threshold, say it is 95 degrees, and you keep on repeating that every second or every 2 seconds, saying that, yes, it is above, it is above, it is above, it does not add any value. And that's the precise reason why we have a separate event called, okay, it's recovered, right? That's the idea of the threshold-based
Amit,
so,
maybe I would like to rephrase. So what really meant is, let's say the OpenDM agent rises temperature, high temperature event. So it will persist it in the cache, and the next interval, if it sees that again temperature is beyond threshold, it won't re-rise. But what I'm asking is, let's say that it is stored only in cache, and now device goes for a reboot. Whatever the previous alarms reported, if it detects the same condition after the reboot again, so can we go ahead and make the device rise all of those events all over again? Already there are earlier raised alarms on the north.
Well, I think naturally, there's two conditions, right? One is there's a reboot of the device, and another is I get disconnected for a while. And the device is still running, right? So if the device is still running, it could still generate and clear alarm conditions, right? And NEM's not going to see them. But then once it reconnects, it won't see any of those alarms, right? Because they're not regenerated again, unless they're queued up, right? If they're queued up, I guess then you get a flood of alarms of events that occurred. If the device reboots, it'll just regenerate all the alarms again from ground zero.
Okay. Yes, Sean, one condition is device reboot. Again, it can detect all the conditions fresh and report. Second thing is, if there is any connective break and there were some alarms that were queued up, should we flush all of them once it is restored? Yes. These two are the points. Okay.
So regarding, I think the last part, right, what you said is, say if there is a connectivity loss, and by the time you regain the connectivity, say alarm happened or an event happened and it got recovered also. So I think the question is, should that be reported?
Yes, Samit, so that we reflect whatever happened on the device to the NEM, so that they are aware of what happened really. Again, it's debatable. Maybe some cases, let's say SFP was plugged out unintentionally by field engineer and he inserted back, but there was a alarm raised and cleared. So it is good that we keep operator informed, whatever happens.
Yeah.
But in some cases, it may cause flooding. We need to see which all such alarms which can flood up.
Yeah. Okay.
So if I have to just reiterate, on the reboot, device can again go ahead and detect the condition all over again, whatever is the latest, and send the alarms. But once alarm is raised in that session of the OLT, it should not rise all again if subsequent KPI also indicates that the threshold crossed. That we should suppress. Once reported, should be held up in the context, but may not persist across reboots. If that is agreeable to all, we will proceed with that.
So Chandra, if I might ask a question there. So what difference does it make if we say that if we want to change the feature and say that, okay, if it needs to persist it across reboots?
If you have to persist across reboot, again, we need to validate that whatever we persisted still holds good or not. If something is not valid anymore, we need to go ahead and clear. Some sort of auditing feature need to come in with. Let's say we reported SFP removed before it. Maybe by the time OLT was brought up back, it was inserted. So we need to check the current condition with whatever the alarm condition before and clear the alarm. So that we need to add in. Do audit.
Yeah, so I think this is at least I would need to think a little bit more on this, because I'm just trying to think from the NEM's perspective. If you give it an say a temperature threshold, whatever above critical, right? And then okay, the device rebooted, but then it doesn't get anything that this condition has recovered. Then the expectation is that the NEM should be able to stitch that story from other events that it receives, that yes, indeed the condition does not exist anymore, right? Else it will keep thinking that the condition still exists.
Yes, Amit, I think that's a use case that is different from SFP, and where device has to better store it and say that condition is not same anymore. I agree for the threshold at least, because once alarm is raised, now, as you said, based on again metrics, somebody has to arrive at that conclusion. I think that would be little out of way than device itself clearing the alarm. It helps if device can store it and retrieve it later and audit what is not valid anymore and clear them.
Yeah, I think that would make sense. So Holger, what you're saying is that with the implementation that you have got there, for every event that is raised, which has a corresponding recovered event, the recovered event will be issued at some point of time or the other, right?
Yes. Mm-hmm.
Okay. So
But this is not. But this is not done by the device.
Yeah.
So yeah. So I think in general the problem is that you can never be sure. I mean, the device can never be sure if the alarm even reached NEM. It could be that there was a loss of communication. So there can always be cases where, for example, you did send the clear alarm, but in that moment the connection broke to NEM, and then you will probably not send it again because you thought that you have sent it already, and you don't want to send it again because you don't want to send alarms twice. So that's why I normally favor more what Andrea suggested, that there is a possibility that NEM could query the count list of alarms, because NEM knows when the connection broke, and then NEM could query the current list of alarms, and then it could generate the clear alarms on its own. And this is what we are doing in principle. I mean, we have netconf, and we have the possibility to get the list of current alarms, and if a device boots, we are having a loss of connectivity, and then if it comes up again, we query the current list of alarms and we compare to those which are raised by us. And if there is any difference, if there is an alarm not active anymore, then we will manually generate a clear alarm. But this is easier because we have something in between NEM and our device. So if you only have the device, I think it would be better to have this logic in NEM, but then you need something in NEM. And this is a little bit also device dependent, how you have to do it. That's why you normally don't want to have it in NEM, which is why I'm quite in favor of a device manager which runs out of the box, which allows you to do all this stuff and you don't have to care in NEM about this.
So Chandra, how about implementing this feature within the device manager? The open device manager, which would ensure a similar behavior, right?
Amit, yeah, 2 points we talked about. One is alarm already raised, we should not raise it again. That is one thing. And second thing is API procedure to query the alarm, active alarms. Amit, are you saying first one or the second one to be implemented on device manager?
No, both of them, right?
Okay. Yes, we can consider. That requires a device to store the alarms and make it available.
So basically, see, what you were saying was that one option is that when the device comes up, it can do an audit on its own.
Yes.
Right? And then depending on the outcome of the audit, send out new alarms or clear alarm or clear existing events. Let's not call it alarms, let's call it events, okay, just for the sake of it. So that is one option. The other is that this functionality can be done by the open device manager, provided you have an API to get the current list of alarms from the device. Right? Then it could do the audit there.
Sure, Amit. We can consider. So are we aligned that we need a RPC for querying the active alarms on the device? Basically RPC on the DMI interface.
Yes, I think that has to be done, right?
Okay. And this query should be at whole device level, including all the components, children under it, or should we consider at hardware component level?
Sorry, I didn't get that, sorry.
Sorry, this query of active alarms, should this RPC be defined to query all the active alarms on the device, putting together all the hardware components, or particular component wise query?
I think we can have both the flexibilities, right? You could query the alarms from a particular component or the events from a particular component, or events from the entire device, hardware device. And I don't think we need to implement all of that in one go, right? So I think we can pick a subset which we need to address initially, and then start with that implementation and let things evolve. Right? We can document those discussions that, okay, in the future, maybe we would want to have more RPCs doing things like that or more flexibilities. But I don't know if we really need to implement all of that in one go.
Sure, Amit. We'll consider for the future, roadmap. Next couple of points we wanted to just discuss in this forum are on the reboot indication. Do we think that NEM should know about a device got rebooted and have an indication for that? If yes, then we need to have a notification defined, maybe as an event at device level. To indicate.
Yeah, I think that should be fine, right? We can introduce a new event.
Yeah, I think that's fine as well.
Next point which Sean brought up is, let's say after after a device reboot or a software upgrade or a device being replaced. So there is a need for doing the audit/reconciliation, understand what is there on the device, and see that is it what actually the operator wanted to have it on the device. So for this audit and reconciliation, what are our thoughts? Are we going to say that okay, the existing Jet RPCs can be leveraged to do the reconciliation, to understand what is there on the device and see what is missing or what needs to be updated back?
This was part of software upgrade, right? This one.
Yes.
Yeah.
Let's say there are a couple of software versions. One is the previous version that is standby, and the latest version that is in the active partition. So due to some reason, if it goes to the standby, or maybe the new version is upgraded. So across the software upgrades, how do we ensure that the configuration is there and that is as required on the device? It is more applicable for this option one we're talking here. How do the NEM components ensure that the right set of configuration is on the device across the software?
Okay, I see that. So basically in this case, because we're persisting configuration on the device itself, and let's say someone swaps out an OLT, and we'd have to have a procedure to either essentially clear the configuration before you connect it up to NEM, or NEM has to discover that it doesn't have the right configuration. Right? I guess that comes back to an audit.
I guess NEM has to do it. NEM has to query the current configuration on the device and update it if needed.
Yeah.
So, so if we are talking about swapping out an OLT, right? So swapping out a device and putting a new device in its place. So it would be a fresh new device, right?
No, it could have been. It could have had a configuration already. And
correct, but from the perspective of NEM, this device was not being managed yet by NEM, right, or by the device manager through the device management interface, right? So from that perspective, it's a new device, and whenever it says a new device, it is going to configure it.
So like, I guess that gets down to the other issue is, if can NEM always see it as a new device and always reconfigure it? So it doesn't have to store persist the data.
Can we do through a counter, like a hash of the configuration, instead of like comparing the all the configuration?
Yeah, I mean, you can have a CRC or something, yeah, a hash or something.
So Andrea, on every configuration update, we need to generate that hash, and that will be validated later, just to have device whether it has the latest configuration. Is that because hash is applicable putting all the configurations put together?
Okay, I guess I have to think more about this a little bit, and we are also right at the top of the hour. So maybe why don't we bring up these points that are left open, the one from before about the events, and this one about the configuration next time. Would that be okay? And in the meantime,
yes,
in the meantime,
yes.
we think about it.
Yes, that will be fine, Andrea.
By the way, sorry, I've still I know we are over the time, but I still have a question. Have we talked about the usage of RPCs like start managing device, stop managing device, and so on for this use case already? Because for me, it sounds a little bit like they're not fitting perfectly. I mean, currently, so I'm not sure if, I mean, currently we do a start managing device, and it's I mean, to our device manager, which runs off the box, it's totally independent. If you reboot the device or whatever, it's under management of that device manager, and it will stay under management until somebody does a stop managing device. But here in this case, if you do a start managing device and then you reboot the device or do a software upgrade, do you have to do a start managing device again after it comes up, or does the device know that it's already managed, or how is this? Did we talk about this already?
We did not talk about this.
Okay.
It's a very good point. It's a very valid point. I'll add it to the notes. I'll add it to the notes.
Thanks.
So I think we don't have a choice there, right? With that architecture, the NEM has to do a start managing device again. There's no other way. Because it's from the client to the server, right? The connection needs to be established.
Yeah, but I mean, actually, you don't need the start managing device at all, because you just open the gRPC connection to the device. I mean, you know the IP address, and then you just manage
so
it.
basically, you don't do the start managing device again, and you just fire away the other RPCs as you need them. Okay.
Yeah, but for all the RPCs, you need the device, the UUID of the device. Do you really need this in this case? It's, I mean, it's a one-to-one connection, so you want to manage the device, and if you use a wrong UUID for that device because somebody switched out a module in that device, should this be rejected by the device, or could we use?
I think we have to look at it, what do I say, from two different angles, right? So right now, the NEM that we are talking about, we have, as in the NEM that we are working with, right, which is integrating the DM from Atran, that is behaving in a certain way, right? And for that NEM, talking with the open device manager, I think makes a lot more sense than directly talking with the device.
Yeah.
Right, because in that case, everything remains exactly the same, right?
Mm-hmm.
And so I think for the other part where we are talking about what the NEM should do when it is talking directly to the device, that is something that we are talking about, okay, what a NEM which directly wants to talk to the device should do, right? And we don't have a consumer or a NEM which is doing that right now. So I think some of those things are, we are putting implicit requirements on a NEM, but that NEM is not really there in implementation as of today.
Yeah,
So,
yeah, I guess you're right. But
I think
perhaps
it is very important that we document all these requirements on the NEM, that we are saying or imposing that if the NEM has to directly connect to the device or to the device agent, right, the DMI interface running on the box, that these are the requirements on the NEM. So I think that is going to be important. Else that information is going to be lost, and it's going to be very difficult when we try to, when someone tries to do an integration.
Yeah, agreed. Totally agree with this. Documentation is key, definitely. But let me think about it, because there might be a few ways we can work around this, or maybe suggest a few different things to them, and we can talk about it more next week, or in 2 weeks from now. I'll see if it's needed. I'll ping you guys and offline and see if a meeting is needed next week. We can schedule one next week. Otherwise, we go in 2 weeks from now. I think you have enough information and data for you to proceed on the implementation without hitting these bottlenecks that we need to review again, right?
But for us to proceed for a week or two, it's not a problem. We can go ahead with the information that is already available. these will help in the subsequent weeks. And yeah, not a pressing need, but yeah, good to have clarified. Yeah.
Okay. Okay. Yeah. I'll think about it, and maybe we can also discuss it on the mailing list or on Slack.
Yes.
If anybody has any thoughts on it. Otherwise, we can discuss it in 2 weeks from now.
Yes. Yeah. Thanks very much for this opportunity to present. Thanks for all your inputs and suggestions.
No, thank you guys. This is great work. This is great work, and I'll make sure to get settle the C++ stuff as soon as I can.
Yes, and we would be just submitting the first level OpenDM agent initial version, and I would request you to review and give your input suggestions. Thanks.
Absolutely, absolutely. I'll gladly do that. Okay.
Thanks.
Well, then, thanks everybody for joining. I'll talk to you on Slack and over the mailing list. Let's continue the great work, and I'll see you in 2 weeks. Thanks, everybody. Cheers. Bye-bye.
Thanks a lot.